Topic 2 is over parent functions and transformations. What you should know from topic 1, covering graphs. Looking at a graph, you should be able to identify domain and range, x and y intercepts, intervals of increase and decrease, intervals of positive and negative, and the asymptotes. If you do not know how to identify these, please watch topic 1 before continuing with this topic. There's a couple things I would like you to add to topic 1. One of the things that we didn't talk about in the last topic was turning points. So turning point is where a function goes from increasing to decreasing. That leads us to the minimum and the maximum, so the highest and lowest y values. Those y values are the y values of the turning points. Those turning points give us our minimum and our maximums. What you'll learn from topic 2, parent functions and transformations. Looking at the equation of a function, be able to identify transformations and key characteristics. Looking at the graph of a function, be able to identify transformations and key characteristics. To start off, we're going to review the types of transformations that we can have in a function. So when identifying what types of transformations are occurring to a parent function, there are 4 pieces we must pay attention to. Whether or not it has any negatives, whether there's any coefficients, what is being added or subtracted to the x, what is being added or subtracted to the function as a constant. We're going to start talking about negatives first. So the negative symbol can be in 2 different places when we're talking about how it transforms a function. Case number 1 is the one that you guys see the most, that we use more often, talking about reflecting the x-axis. So that's when that negative symbol is outside of any grouping symbols that might be in your function. That negative on the outside is taking whatever y values you're getting and changing them to negative. So that keeps those x values the same, which is why we reflect across that x-axis. Those x values stay the same while the y's become opposite. Case 2, we haven't dealt with as much, but that's reflecting the y-axis. So that is when you have a negative symbol inside the grouping symbol. So we have different types of functions that can have different grouping symbols. It can be parentheses or radicals or absolute value bars. So if that negative symbol is inside any grouping symbols, then it is reflecting the y-axis. So because that negative's inside, it's taking those x values and making those negatives, and it keeps those y values the same, which is why we reflect across the y-axis. Next, we're going to talk about the coefficients. So that's that a value that we've talked about. So the coefficient can be in 2 places, and it can either be greater than 1 or between 0 and 1. So how that size of that a value affects it depends on case 1 or case 2. Case 1 is the one that we have worked with the most. That's working vertically, stretching or compressing. So that a being multiplied on the outside is affecting the y values, which would cause the graph to stretch or compress along that y-axis, and the y-axis is the vertical axis. So that is why that is a stretch or compress vertically. If it is a whole number greater than 1, then you stretch, and if it is a fraction between 0 and 1, then you would compress vertically. Case 2 we don't deal with as often, but that is when the a is in front of the x inside of the grouping symbols. So that's affecting just the x values, which would cause the graph to stretch or compress along the x-axis, which is the horizontal axis. So that stretches or compresses horizontally. On the size of the a's in this one, it is opposite. The size of the a's for a vertical stretch or compression. So if my a value is greater than 1, I'm going to compress. If my a is between 0 and 1 or some type of fraction, then I'm going to stretch. The next piece we want to pay attention to is what is being added to x. That's that h term. So a number can be added or subtracted from x inside the same grouping symbols x is in. So if we have minus h, that means we're going to shift right h units. And if we have a plus h, that means we're going to shift left h units. So remember, when that number is inside the grouping symbols, it goes the opposite direction. So if it's a minus, it's a positive direction, and if it's a plus, it's a negative direction. The last thing we want to look at is what is being added to the function as a constant. That's that k value. A number can be added or subtracted outside of the grouping symbols. So if I'm adding k, then I'm shifting it up k units, and if I'm subtracting k, I'm shifting down k units. Okay, so now we're going to look at the parent functions. We're going to talk about their names, their parent equations, the transformation equations, and then what that transformation can look like using Desmos. So the ones that we've talked about before that we will go over again are linear, quadratic and cubic, square root and cube root, absolute value, exponential, logarithmic. And the new function that we're going to talk about is rational. And a rational function is just a function that has fractions with the variables inside. The first one we're going to look at is a linear function. So a linear function is any function whose graph is a straight line. So we have the parent function. You will see y written as f of x through the rest of these because they are all in terms of a function and not just an equation. So f of x is the same thing as y. So f of x equals x is the same thing as y equals x. You can see over here that linear parent function that we have. I'm crossing at the origin. I'm not shifted up or down or left or right in any way. If I take a look at what this graph looks like, if I do start shifting things, so if I change this a value, the larger that a value becomes, the steeper it gets. And if I switch it and it becomes negative, then that's that reflection. And the bigger the whole piece of it gets, the steeper it gets as well. So the steepness of negative 3.8 is going to be the same steepness as positive 3.8. Let's take this back down to 1. Oops. And look at how that h value can affect it. So h value is going to shift us left or right. This will say plus or minus, and it's not going to go in the opposite direction when you're looking at your axis. If you were to plug it into that equation, it would change because that basic equation is x minus h. So positive h is going to move it right. Negative h is going to move it left. Positive k moves it up. Negative k moves it down. But if we look at this, if I go positive 2 for the h direction, okay, and then let's reset it, and then let's go negative 2 in the k direction. Those are the exact same graph. So when you're looking at this linear parent function, those h and k aren't always separate numbers. Sometimes they have simplified this down completely, and it ends up looking like an equation in slope-intercept form. That's the y equals mx plus b. That b value is your y-intercept. So when you're looking at this equation in terms of the transformation function, this k value is not always your y-intercept. If you have an h value, then it changes what that y-intercept can be. At this point, you should be able to identify the parent function, identify linear transformations from a graph, and identify linear transformations from an equation. The next function we want to talk about is the quadratic function. The name quadratic comes from quad, meaning square, because the variable is what's becoming squared in this function. So our parent function is f of x equals x squared. That transformation function, that a value is outside the parentheses because we are going to mostly be working with vertical, and then that h value is inside the parentheses, and both of those pieces are being squared by that exponent. And then your k, that is outside of any grouping symbols. So we can take a look at that quadratic graph. Reset these back to 0. So we talked about stretch and compress a little bit. So the higher this a value gets, that's the more it's going to stretch. But we're stretching vertically, so that means it's going to be reaching up higher, sort of stretching up, and it's just becoming skinnier. So you can't always think of stretch and compress in terms of the width. Okay, so if I become negative, that reflects it across that x-axis. And then if I change that whole number, the larger it becomes, the skinnier that graph becomes. That h value is going to move it to the left and to the right. And that k value is going to move it up and down on the graph. Okay. So you can see on this parent function that vertex is at the origin. So when you're trying to identify the types of transformations that are happening, you want to focus more so on that vertex. That's going to tell you how many units it's shifted left and right or up and down. You have to use other means to find that a value. At this point, you should be able to identify the parent function, identify quadratic transformations from a graph, identify quadratic transformations from an equation. Next, we're going to talk about cubic and higher exponents. The functions of quadratic and higher exponent equations are set up the same way. So that's in terms of where the grouping symbols are, where the a, h, and k values fall. The difference between the quadratic function and the cubic or higher exponent is just that exponent now is written as an n. You can fill it in with any number that you would like. If we had a 3 as my n value, that would make it the cubic function, and that's that parent graph we have over here that looks a little bit like an S. So if we look at the parent function transformations, so that a value, that's still that stretch or compress. So the higher it gets, the skinnier that graph is getting. It is stretching up and down, so it is becoming skinnier. That h, again, shifting me left and right. And k shifts up and down. At this point, you should be able to identify the parent function, identify cubic transformations from a graph, identify cubic and higher power transformations from an equation. Next, we will look at the square root function. It is also called a radical function, but specifically this is one that has the index of 2. So if your index is not written, remember it is assumed to be a 2. So my parent function is f of x equals square root of x. And for that transformation function, the a value is the coefficient of the radical, and the h has to be in the same grouping symbols as the x, so that h is inside the radical with the x. So anything under that radical is what's shifting it left and right. That piece on the outside, that k value, that's going to be shifting me up and down. You can take a look at this one. So as that a value changes, it is increasing the slope in this one. It's not necessarily making it skinnier because it is a line that's continuing to the right forever, but it is making that slope somewhat steeper. H is going to shift me left and right, and k is going to do that up and down shifting. At this point, you should be able to identify the parent function, identify square root transformations from a graph, identify square root transformations from an equation. Next, we're going to talk about cube and nth roots. The functions of radical functions with higher indices are set up the same way. So the difference between these and the one before is that little number in front of that radical. It's written as the symbol of an n. You can write any number that you would like to there. If we were to put a 3 where that n value is, this is the graph that we would get. Okay, that a value is still outside, the h value is still inside the radical, and that k outside being added or subtracted. Look at the cubic function. cube root function, I apologize. So when it's stretching, it's mostly flattening out against that y-axis. So that steepness, like we said before, h moves me left and right, and k is going to shift me up and down. You should, at this point, be able to identify the parent function, identify cube root transformations from a graph, identify cube and nth root transformations from an equation. Next, we're going to talk about absolute value. Absolute value means the distance, which gives us positive values. So if you look at the graph on the right, those positive values are all positive y values. We can put in any negatives we want for that x, and it will only spit out positive values. So for our parent function, we have f of x equals absolute value of x. And for my transformations, I have that coefficient of a is outside the absolute value. The h is inside those grouping symbols, those absolute value symbols, and the k is at the end being added or subtracted. So we can look at the graph of the absolute value function. So that a value, again, is going to make it skinnier or a little bit flatter. Negative is going to reflect me across that axis. Oops. That h value is going to shift me left and right, positive, negative. That k value is going to shift me up and down. At this point, you should be able to identify the parent function, identify absolute value transformations from a graph, identify absolute value transformations from an equation. Next, we're going to talk about the exponential function. So exponential is when you have a base that is a constant number and the exponent is a variable. The parent function, you will see sometimes just as b to the power of x. This base can be any number that you want it to be. For the graph, in order for you to see it visually, I did have to plug a number in. So I used 2. That's the most common one you'll see. So this is what you will use for the parent function as far as transformations that are occurring. So if you see a base of 2 already there, you can assume that that's not a transformation that's occurring to the function. That is the base itself. So then for the transformation function, your a coefficient is in front of that b value. The h is in the parentheses where that exponent is. So x minus h is my entire exponent for my transformation function. And k is on the end being added or subtracted. So for this one, I do have a b value that we can look at and see how that b value affects my graph. So we're just going to change that b value to a 2, which is what we have on our parent function on the other graph. And so we'll just look at how this can transform. So if I change that a value, if I'm multiplying that base by a constant or a coefficient, the higher it gets, the higher it's reaching to the sky, the lower it's compressing, it's flattening out more against that axis. My h still moves it left and right. K up and down. So then let's see how this b value can actually affect it. So depending on how my base changes, the higher it gets, that's just the steeper it gets. But then when I switch to a negative, it's reflecting across that y-axis now. Okay, so when I have an actual base that is negative, you can see my graph disappears completely. Okay, for exponential functions, that is something that can't be true. You cannot have a negative base. So all of these do have to be positive. Okay, but if it is a fraction, that is when we are reflecting. Okay, that is when it becomes that decay function. And when it's the whole number, remember that is when we have that exponential growth. At this point, you should be able to identify the parent function, identify exponential transformations from a graph, identify exponential transformations from an equation. Our next one is logarithmic functions. So a logarithmic function is an inverse of an exponential function. And it's a function that's written with a log and a base. And so we've talked about before, if it doesn't have a base written, we assume that it is written as a 10. Okay, so log base b of x, this b can be any value that we want it to be. I used a base of 2 for this parent function just so that it looked more similar to the exponential function on the previous example. For our transformations, the a is the coefficient still, and that h value, it has to be grouped now. That x didn't originally have any grouping symbols, but it is being input into this log function. It is part of this logarithmic. Okay, so x minus h or x plus h would have to stay in parentheses, and then anything being added or subtracted at the end of the log outside of any grouping symbols, that's going to be your k value. So for logarithmic, again, I'm going to start with a b value of 2 just because that's easiest for us to work with. So depending on how that b changes, the higher it gets, the less steep I'm getting. And then when that becomes the fraction, that's when it's reflecting. And then when it turns negative, that's when it disappears completely. You cannot have negative log functions. Let's go back to 2. So that a value, that's going to be the coefficient in the front. So that's kind of just changing that angle a little bit, right? So we can reflect if I become negative. And then, so the higher I get, the more I'm reaching to the sky. The smaller the number, the more it's flattening out to the ground or compressing. Oops. The h value, that's going to shift me left and right. And then your k value, will shift you up and down. But if I go all the way to 10, it doesn't even look like it's moving up. That line just looks like it's flattening out against that y-axis. That is because we have a vertical asymptote at y equals 0. So if I were to change this, then I could see that difference. But it's still just flattening out to one line. Whatever I have that k value at, it's going to match up. At this point, you should be able to identify the parent function, identify logarithmic transformations from a graph, and identify logarithmic transformations from an equation. The last one we're going to talk about is the rational function or reciprocal function. So this is a new one that we're going to talk about. So normally a rational function is written as a fraction with numerator and denominator as polynomials. When we get into more rational functions next week, we will talk about those polynomials more. But for the most part, for a parent function, it doesn't have polynomials. This is actually called the reciprocal function. And so that's just how it's relating that y and the x value. So a reciprocal, right, that's when I can flip it upside down. So if I were to have just y equals x and I wanted to flip my x upside down, I would have to turn it into a fraction first. So I would have x over 1, and then reflecting it, that would give me 1 over x. That's how you take the reciprocal. So this is the parent function of the reciprocal function. And so if you can look closely, there's a dotted line right here. Those are our asymptotes. So this is a vertical asymptote at y equals 0, and then we have a horizontal asymptote at x equals 0. So here, that a value is on top. It won't always be written on top. You may see a 1 on top and then a coefficient out to the front. So a could be outside, but a, if it is a whole number, when you are multiplying a whole number times a fraction, you multiply just on top. So if it is just a whole number out here, you can just multiply it by whatever is written on top to simplify it down. That h is going to be in the denominator where that x value is, and then the k is going to be outside of the whole fraction. So we have this last function. Let's reset these. Okay, so this is our our parent function, and we don't have a b value anymore. So depending on how I change that a, right, the more it's increasing, that's stretching, but what it's really doing is stretching away from the y-axis or the x-axis. So it looks like it's leaving the x-axis from both of those sides. And then if I become negative, that's reflecting it. And then again, that a value is increasing, so it's stretching. Okay. H is going to shift you left and right. That's also going to tell you, right, when my H is 0, my vertical asymptote is at 0. When my H is at -4, that vertical asymptote is also at -4. So your H is going to tell you what your asymptote is. That K is going to shift you up. So when my K is at 0, that vertical asymptote for H. K is your horizontal asymptote. So if I'm at 0, that's a y equals 0 asymptote. And then if I increase it to 3, then that horizontal asymptote is now y equals 3. At this point, you should be able to identify the parent function, identify rational transformations from a graph, identify rational transformations from an equation. Now that you're done, go ahead and take topic 2 quizzes. Let me know, which topics did you struggle with after the lesson? For topic 3 next week, we're going to start talking about piecewise and polynomial functions.